Good afternoon, grade 8s. This morning we talked about probability. Some of you remembered it from last year, but very, very few of you. Know that this isn't a very long unit or very tough unit. There won't be a unit test. There will be 2 assignments that we're going to do, and they should be fun once we get the basics of it. Like our computers that we're doing right now, it's kind of logical when you do it. We draw out some pictures of the diagrams, and then you look for the formula, and you do exactly what it says, and you should be just fine. So anyhow, what we need to know is what is probability, and as we discussed today, probability is just basically the likelihood of an event happening. The event changes, whether it's a flipping of a coin and you want to get heads, or rolling of a dice and you need a 5 or higher. That's the event, that's what you're doing, and probability is how many times will that happen, and you get to see if it's a good thing or a bad thing, or if there's a really likely chance of it happening, or if it's not very likely or unlikely. Anyhow, the next part of the note that we took already today is there's 2 types of outcomes when we do a random or chance event. Now remember, we talked about a random or chance event today, and that random would not be to draw colored cubes from a clear bag. There is no randomness in that. You can see through the bag. But if there is no predicting what is going to happen, that is what we call a random or a chance event. Anyhow, the 2 types of outcomes that we can have and that we'll be using in our formula are specific outcomes and total outcomes. And you heard me say it, there is a formula. There's almost a formula for everything we do this year. And you're going to take it, you're going to substitute, we're going to do just great with it. But, oh sorry, before I get there, in red, specific outcomes are what you want to have happen. So if this was flipping a coin and I really wanted heads, heads would be the total or the specific outcome I'm looking for. And the bottom on the next one are total outcomes. Total outcomes are the total number of possible outcomes. The ones that you're looking for and the ones that you're not. So with a coin toss of heads and tails, there would be 2 total outcomes. Remember, we wanted the heads, but there's also a possibility of tails, so there would be 2 total outcomes. Anyhow, the formula now that we looked at today and didn't do too much with it because we were just exploring, the formula is the probability of an event is the number of specific outcomes over the number of total outcomes. And then we just divide it. We're going to talk about the different ways that you can present your answer, and you have to know the different ways. It's not really that big of a deal once you get this far and you put the right numbers in, but there are different ways to express it. So I'll give you a for instance over on the next page. So remember, we did something very similar today. I'm going to say this is a bag of marbles, and it's in a bag that you cannot see through it. And the first thing to do is determine the number of marbles and the colors of all the marbles. So just from looking, I see that there are 6 red, and there are 1, 2, 3, 4, 5 black, and there are 3 green. So that's just my background information, and I know total that will give me 14 marbles altogether. That just helps me before I get started. Now, there could be many different questions asked, but for this example, I'm going to say, what is the probability, and it'll look just like this, what is the probability of a black marble being pulled? So the probability of black. This could say probability of green. It could be probability of not red, in which you would combine 2 different. But for the first one that we're doing, it just says, what's the probability of pulling a black marble? So in this case, we have to go back to our formula. And remember, our formula is specific outcomes over total. I'm a little bit out of space, but really that's specific number of outcomes over total number of outcomes. You don't have to write it every time. I do like the bare minimum of specific over total. Anyhow, specifically, we are looking for black. So you'll have to go back, see how many black there are, and there are 5. And then you go back and says, okay, what is the total number of outcomes? Remember, we have to combine everything that's there. So we'd have to take all 3 of those. I already totaled them up. So the total number of outcomes is 14. Now here comes where we can write this as 3 different answers. A, we can leave it as this answer here. It's in fraction form, but we actually say, if we were to speak it, we say 5 to 14. 5 to 14. Now, when I say that, you might say, well, I remember something like that. I remember that as a ratio. When you hear that, and this fraction, 5 over 14, is a ratio, and you write it 5, which is your numerator, to 14, just like that, and you say it the exact same way, 5 to 14. So that's the first way you could leave it. There's the second way if I say express as a ratio. And the third one, which many of you did today, was to take that and put it into a percent. Now, good math skills, you should know how to take any fraction and put it into a percent. It should be knowledge by grade 8 that you take the top number and divide it by the bottom. So what we have to do is 15, I'll write it again right here, 5 divided by 14 is equal to about decimal 3, let's go decimal 36 because I rounded a little bit. And in order to get that to a percentage, we multiply that by 100. Please don't go looking for your calculator now, although you probably would have used your calculator for that. But once we have it at this, you know that multiplying by base 10 numbers, we just move the decimal place over 2. So this would be 36%. So if I asked you to just leave it in fraction form, it'd be 5 over 14, pronounced 5 to 14 if you were to tell it to me as a probability. You might write it as a ratio, which would be down here on the left. And if I asked you for a percentage, you do the same work, divide it, multiply it by 100. So you have to be prepared and ready to do it all 3 different ways. Besides that, that's all we have to do to start and be ready for tomorrow. So I'm going to show you one more, and then I'm going to give you a little hint on where we're going the next day. Okay, so the next one we're going to do is the probability of getting an odd number on a 6-sided dice. And we know we can spin this dice over and over again, and it'll come to all different possibilities. And on a 6-sided dice, the numbers are 1 through 6. I know I might be insulting some of your intelligences here, but we have to just write it out so we can see the whole thing. And we are only concerned with the odd numbers. That's our specific in this case. So over to the right, I've already started. I put my formula. I put probability of an odd number. I didn't have to draw that. I was just, I don't know, feeling a little crazy. I wanted to draw that. Anyhow, the next thing is always to put our formula. Remember, for probability, specific number of outcomes divided by total number of outcomes. And in this case, what I am looking for, please remember again, you don't have to keep writing this over and over and over again. Specific over total will be fine. But there are 3 specific outcomes that'll give me what I want. There are 3 times when I'll roll this dice that it will give me an odd number. And then my total outcomes are all of these. You just don't take the ones that you like, you take them all, so there's 6. Remember that this is one of the ways that we can answer a question, but back to fractions, we do have to do something with this. This is a correct answer, but it can be more correct. We need to reduce. And remember, when we reduce, we look for a number that will go into the top and the bottom, into the numerator and the denominator. So with a number like 3/6, it is well within your capabilities to know that 3 goes into both of those numbers. And what you say is, okay, 3 goes into itself 1 time, and 3 goes into 6 twice. So 1/2 is an equivalent fraction of 3/6, and it's a much better answer. So that's it in fraction form. Remember, our 2 other forms are percentages and ratios. It depends what I'm asking for. You don't have to put it in 3 different types every time. But our ratio answer, just so you would see it again, will simply be the top number, 1 to 2. And if we were to do our percentage, I'll just put the symbol for percentage. Remember, we do 1 over 2. That truly is a division question. that will equal decimal 50. To take that into a percentage, we multiply that by 100, so we'll have a 50% probability of getting an odd number. That's where we're going to start tomorrow, but I'm going to show you one little quick piece of where we're going to end up by the end. All right, just for a little preview for tomorrow, what if we had two things? We had one coin before, we had one dice before, but what if we have two coins and we have to combine different elements? And I was going to say here, what is the probability of flipping both these coins at the same time and them both coming up heads? Well, we're going to get into something called tree diagrams tomorrow. And what you have is you have to take what you have and branch it and count all the possibilities. So what we have to do here is look at the first coin. So we have the first coin, and we know that the first coin that we could flip could be a head or it could be a tail. That's really coin one. Coin number one. You could have a head or a tail. Now when I go to flip coin number two, it is, we've already flipped coin number one, so it is an offshoot. So remember, the first one could have been a head, but for coin number two, it also could have been a head. Similarly, the first coin could have been a head, but the second one might have been a tail. And this is what comes into a tree diagram. Now that's two, but you could have started with a tail. We could have flipped that first coin, a tail might have come up. When you flip the second coin, you might get a head on the second one, or you might get a tail. So now when you're looking at this, you've got to be able to see what all the possibilities are. And you do it this way. Here is one possibility. I could have had head. A second possibility could be head, tails. A third possibility could have been tails, head. And the last possibility could have been tails, tails. So, remember, if I'm asking for only when two heads come up in a row, and I have specific over total, what do you think we would put as the top and the bottom? We will pick it up here tomorrow, and you'll see that this is just another step, and you'll be able to complete them no problem. Good luck. There was no homework tonight, but if you want to review this, it's always helpful.